Let us go to the properties of these carbonyl compounds. In the sixth property, that is base catalyzed reactions we were doing. In that also the first one condensation, that is aldol condensation, we have finished. In that reaction, one carbonyl compound in fact adds on another carbonyl compound. After addition, you get a beta hydroxy carbonyl compound that undergoes dehydration. The final product is a condensation product, that is why it is called aldol condensation reaction. In this, it is a second reaction is a Cannizzaro reaction. In this reaction, it is in one way it is slightly different from the rest of the other condensation. In all the condensations, molecules join, and this two molecules, if they join, single the molecule will be formed. But here in the Cannizzaro reaction, two compounds will participate, one undergoes oxidation, one undergoes reduction. The two compounds parallelly they undergo redox reaction. In fact, one undergoes reduction, the other one the oxidation. It is a mutual, the oxidation and the reduction. And the conditions required here, what conditions are required for the Cannizzaro reaction is, the first condition is only aldehydes, that too without alpha hydrogen, without alpha hydrogens. So, if compound contains hydrogens, alpha hydrogens, it undergoes aldol. But however, in aldols, aldehydes as well as ketones both undergo, but here only aldehydes, because it is a mild oxidation. Mild oxidation, we have seen aldehydes readily undergoes this oxidation. So, therefore, the only aldehydes undergo this reaction, that too without alpha hydrogen. Second condition required is the strong base is required. For this strong base, it is the example 50% concentrated NaOH in fact, or KOH. In some cases, barium hydroxide and calcium hydroxides are mentioned, but 50% means it is highly concentrated, and NaOH or KOH or OH minus may be simplified representation also you can do. Examples for this aldehydes without alpha hydrogen means a carbon with aldehyde is there. Yes, this is your aldehyde function. So, the conditions required is that the first condition is only aldehydes, that too without alpha hydrogen. Alpha hydrogen should not be there. If alpha hydrogen is there, it undergoes aldol condensation. That is why here alpha hydrogen should not be there. Second condition is a strong base which is common to the aldol condensation, that is highly concentrated base like NaOH or KOH are required. So, some examples for the carbonyl compounds which undergo Cannizzaro is the first member of the aldehyde, that is HCHO. This is your aldehyde function. There is no alkyl group. So, there is no alpha carbon. The question of alpha hydrogen does not arise. You can have a alpha hydrogen aldehyde, alpha carbon is there, but this alpha carbon is having some groups like all methyl groups you can take, all ethyl or methyl, ethyl propyl, or all different three alkyls also, I have no problem. Another one is alpha carbon is there, but attached to the in a benzene, it is one of the member. So, this is in fact alpha carbon, that this is attached to one side double bond, one side single bond. So, there is no hydrogen. So, alpha carbon may be there, but no alpha hydrogen, no alpha hydrogen. Alpha carbon is also not there. In some cases, you too can take like this, a carbonyl, that is aldehyde, one more aldehyde. So, in fact, this carbon is alpha to this one, but the concept of alpha is not by position, by function it is. Actually, the alpha carbon possessing the hydrogen can show hyperconjugation and participate in the aldol condensation. That is, the hyperconjugable hydrogen is the required actually for the aldol condensation, for which this carbon should be desaturated. That means, the carbonyl carbon, immediate carbon, next carbon should be saturated, on which hydrogen should be there. So, here by virtue of position it is alpha, to the functional group. This is carbon on which hydrogen is there, but can this show the hyperconjugation? No, both are unsaturated only. Therefore, it is not actually by positionally, but it is conceptually. Alpha hydrogen means hyperconjugable or tautomerizable or enolizable. That concept is important here. So, therefore, in all the compound there is no hyperconjugation or the tautomerizable hydrogens are absent. Therefore, all these not undergo aldol condensation, and they undergo Cannizzaro reaction because they are all aldehydes. If a ketone, if it is taken no alpha hydrogen, that will not come under this category. Now, let us take what happens when the formaldehyde is taken. A formaldehyde, if it is taken as per this definition of this one, two carbonyl compounds undergo reaction in presence of a base and slight heating. One undergoes oxidation, that means it will become into the acid. Next chapter it goes promotion. Another compound goes to the back chapter, that is the last chapter, that is the alcohol. One carbon alcohol is methanol. So, one carbon aldehyde will become into one carbon acid. The carbonates will not increase or decrease. So, one carbon aldehyde will become oxidized to one carbon acid, that is formic acid. So, one carbon aldehyde formaldehyde reduces to its alcohol, that is methanol. So, a methanol and formic acid is formed. However, practically if you think, there is this highly concentrated base is there. Therefore, in the answer you find a carboxylate anion, its corresponding salt. For example, if KOH is taken, K plus will be there. So, one answer is potassium formate, the other answer is methanol. Then how can I get really the formic acid? Means you can acidify it, add some dilute HCl or H3O plus. If you write acidification, will really give the mixture of formic acid and the methanol. Similar the case with the benzaldehyde. I will take benzaldehyde. What happens? Benzaldehyde, one becomes into benzoic acid, right? Two are participating. One becomes into benzoic acid. The other one becomes into the benzyl alcohol. So, number of carbons I said will not increase or decrease. Benzene plus one carbon. So, here also it is not phenol, it is benzene plus one carbon OH. That is benzyl alcohol, not phenol, it is known as benzyl alcohol. Other one is benzoic acid. So, to get this particular two compound, first the condition required for the aldol condensation, that is Cannizzaro reaction OH minus. Second one is acidification, H3O plus or dilute HCl or at least H plus if you write, then only I can write acid. Otherwise, the sodium or potassium salt of the acid you have to write. So, this has nothing to do actually. The first one is only the reaction, Cannizzaro reaction. Second one is only in order to get the acid from the salt, we are neutralizing, or acidification will give the acid. And like that, this is for example, if I take a neopentyl aldehyde, neopentanaldehyde, okay, this is all carbons I will take. Now, in this case, two compounds are used. One will become into neopentanoic acid, one will become into the corresponding alcohol, that is neopentyl alcohol. Several compounds you can take, not necessarily only the benzaldehyde, you can take a furan with aldehyde, right. Similarly, a pyron with aldehyde and so on. Several types of the compounds may be taken. One becomes into aldehyde, one will become into the acid. That is a mutual oxidation and the reduction in presence of the base. So, final product acid, generally after the treatment with OH you will get a salt only, but acidification will give the actual acid. So, this is the net reaction, different starting materials you can choose. Furan aldehyde will become furoic acid and furyl alcohol and so on, all different types of the acids you can write it. But let us see how the mechanism is operating the reaction, what exactly the OH minus is doing in this reaction, helping the reaction or working as a catalyst. Let us identify. Let us see the mechanism of this Cannizzaro reaction. I will take benzaldehyde as a sample compound, and the OH is going to we are using the catalyst. So, the OH when this polarizes you will get a minus sign plus. On the plus the O minus, the OH minus will attack. Then consequently you will get a phenyl with the C, okay, the H and the O will become O minus and there is a OH minus attack. When O minus comes back, again double bond will be formed, the valency will become tetra. Now, the newly OH has come, so if this becomes double bond, 5 bonds will come. Let us imagine if the OH comes back, you will get back the original one. So, such type of reactions will be going on, taking place in addition of OH will give it and OH removal again comes back. But instead of the OH coming back, if H minus is expelled out, then what happens? This is what condition. So, this becomes into benzoic acid in fact. So, one compound you got the answer ready, that is benzaldehyde has become into benzoic, that means it undergone expulsion of this H minus is nothing but the oxidation. But here you will have a H minus also, okay, H with the pair of electrons H minus, this is known as hydride ion. So, the hydride ion and benzoic acid are formed. The moment H minus ion is formed, take the another benzaldehyde and show that hydride ion attacks on this one, just like OH minus attacked on the carbocation. Now, this H minus attacks on this carbocation. This in fact that is ion and this is ion. So, the ion formation is the only slow step, it seems. This is the slow step. So, here the OH minus attacking plus is also fast step, it is identified. The OH attacking is a fast step. But this compound becoming into H minus, that is anion formation. Remember that in the aldol condensation also I made this point very clear. Anion formation, removal of the proton leads to give the one compound into carbanion. Once the anion comes, again the step will be now the fast step only. So, the H minus attacking will be again it is fast because ion attacking on the ion. So, this will become into the now the 2 hydrogens with the O minus, that is in fact benzyl alcohol is also ready. Only thing is one problem is one hydrogen is missing here. Now, the combination of benzoic acid and benzyl alcohol together will undergo a H plus exchange or change of the proton or exchange you can take. So, from this side to this side, one hydrogen will be H plus will be exchanged from there to here. Now, this will become into benzoic acid and this will become into the benzyl alcohol. Why this is happening means benzoic acid is a strong acid, would like to give the proton. Benzyl alcohol is a weak acid, it won't want to give, but already you have shown it is as if it is donated, which is not correct. So, immediately the proton will taken back. These two cannot exist in the flask. See, the question may be asked, in a flask I can take both acid and alcohol, both can exist, one acid one alcohol can exist, both will have the protons, both exist. Both can exist as anion and anion, benzoic acid anion, benzyl alcohol anion. Excess sodium is added, both will become sodium salt, sodium hydroxide even. But this becoming into anion, that into acid cannot exist. That anion, now what happens you see, if the proton is given to here, this will become into the benzyl alcohol, that will become into the benzoic acid anion. Now, this mixture if you acidified with the dilute HCl or H plus or you can say H3O plus, that will become into the benzoic acid. Otherwise, till that time the potassium salt of benzoic acid will be the answer. So, I will repeat once again the salient features of this reaction. First step is a base OH minus attacks on the first benzaldehyde. On the benzaldehyde there is a, if you open it, minus sign plus will be there, on the plus the OH minus is attacked. This is what your catalyst OH minus. After attacking the OH, you will have that O minus anion is there. This anion when it comes back, if OH comes out again you will get it, that happens anyhow. But instead of the OH minus coming, if H minus comes and this becomes into benzoic acid and that H minus is shown as a hydride ion which will attack on the second molecule of this is, let us say, first molecule of benzaldehyde. This is another molecule of the benzaldehyde. On the second molecule, that H minus hydride ion is attacking. This is a fast step, this is the slow step. So, out of these so many steps, the slowest step is also known as what? RD step, that is rate determining step. Slowest steps are called RD steps. So, I can ask which of the following, this to that, this to this to that, like that 4 or 5 steps I will give and ask, identify the rate determining step. Rate determining step will be always the slowest step. Now, can you guess that the H minus attacking on the C plus, will it be fast or slow? It will be fast only, because ion attacking on the ion will be always 0 minutes time, that is 0 time you will get it, very spontaneous or instantaneous reactions. Only from this anion, a carbanion from this compound, H minus hydride ion formation will be the slowest step here. That attacking will be again fast, and these are all just neutralization types of the steps. Therefore, the RD step is very important to identify, that is hydride ion formation is the slowest step, that is the rate determining step. And then finally, what you will get is, out of 2 benzaldehyde, one benzaldehyde is become into oxidized into benzoic acid, another one reduced into the benzyl alcohol. So, this is the mechanism, a small mechanism, but you must remember that OH attacking, and when instead of OH minus coming out, now H minus has come, that attacked on the another molecule, which is the crucial point or the important point in which reduction and the oxidation. Removal of H minus is oxidation, that H minus adding to the other compound is the reduction. Therefore, one compound undergoing oxidation, the other compound undergoing reduction. 1 or 2 slight different examples, like if I take a mixture of benzaldehyde and formaldehyde, here both are eligible for the Cannizzaro reaction, but I have taken 2 different varieties. You can call it as a mixed Cannizzaro reaction. Mixed Cannizzaro reaction. Okay. In this Cannizzaro reaction, as I said, when 2 benzaldehyde, one will become into oxidized and other will be. Now, this is 2 different compounds. So, therefore, which undergoes oxidation, if you decide, the other automatically the other one which undergoes reduction is identified. So, first which undergoes oxidation, on which OH minus first attack, that is the one which undergoing oxidation. If OH minus, will it attack on the formaldehyde or benzaldehyde? Now, the step 1 is a nucleophile attacking. So, we have already given some norms to recognize which is the more reactive towards nucleophilic addition. I have given a big list, in fact, formaldehyde, acetaldehyde, benzaldehyde, all aldehydes comes first, then ketone. In the ketones, the acetone, acetophenone, benzophenone. So, when aliphatic and aromatic, when aldehydes and ketones, aldehydes are more reactive. Within the aldehydes, aliphatic more reactive. Within the aliphatic, again small one, big one means small one is more reactive. So, based on that, one is aromatic, one is aliphatic, here comes the aliphatic. So, OH minus first attacks on the aliphatic, therefore, this undergoes oxidation, that undergoes reduction. So, final answer, however, requires the 2 conditions. First one, maintain the basic medium, heat it, and you get the real Cannizzaro reaction. Afterwards, acidification. Let me write the answer now. So, benzaldehyde is, formaldehyde is oxidized to become the formic acid. Benzaldehyde is becoming into the benzyl alcohol. Right? It is justified, because smaller the carbonyl compound, undergo oxidation also easy, and not that exactly, but conceptually the OH is the first attacking species, on which compound it attacks, naturally formaldehyde. So, that undergoes oxidation to become the formic acid. We too have a slight, this is a mixed Cannizzaro reaction, but if the compound is like this, one aldehyde is there, another aldehyde is there, right. This is the 2 aldehydes. Now, in this case, it is called what? Intramolecular Cannizzaro reaction. That means, in this reaction, second molecule not necessary. Within the given compound, 2 aldehyde groups are there. So, one group let us oxidize, one group undergoes reduction. So, both are identical, therefore, where the OH attacks question will not come, either one you can write, but after acidification let us write, because the complication will not be there, one will become acid neutralization also. So, one will become into acid COOH, the other one will become into alcohol. Now, this compound is it's a ethane diol systematically named, but has a common name called glyoxal, AL, glyoxal. This is called glycolic acid. Glycolic acid. A carboxylic acid have got it side by side, 2 OHs is there, glycol, 2 COOH, oxalic acid, okay, glyoxalic acid or glycolic acid. If aldehyde is there, we have a glyoxalic acid, but this is a glycolic acid. So, you can have 2 COOHs, 2 OHs and so on, but in this case one is oxidized to acid, the other one is becoming into the alcohol. If the compound is with a slight variation, that if this compound has got a slight variation, now the other side there is a carbonyl. Now, if I put a methyl here, now this carbonyl has a alpha hydrogen. So, therefore, I should not put a methyl, but you have a chance of taking benzaldehyde type benzene group if it is there, phenyl ring if I take, there is no alpha, there is no alpha hydrogen. So, therefore, once again it is eligible for to go the Cannizzaro reaction, but one is aldehyde, the other one is ketone. So, as per the rule, actually ketones will not participate, but when aldehyde undergoes oxidation, ketone undergoes reduction. I said ketones undergoing oxidation is difficult, that is why ketones will not participate, but here ketones participating and becoming into alcohol, no problem. So, this part will become into reduction, this part will become undergoes oxidation. So, therefore, in Cannizzaro reaction if you apply on this compound, again let us write a H3O, that is acidification also join it. Now, you may have another question on which the OH attacks mean, that is aldehyde, that is ketone, and that too it is aromatic ketone, much more less reactive. So, OH attacks on this compound logically and becomes into the oxidized, that is COOH is formed, and this side it will become the reduction, that means CHOH is formed, and a phenyl, okay, a phenyl CHOH, that is called actually benzene with a aldehyde, that is benzaldehyde adding HCN followed by hydrolysis also will get the same, that is called mandelic acid. So, that is a phenyl ethanoic acid containing a hydroxy group, it is called commonly has a name, common name mandelic acid or mandalonic acid. So, this compound will give the, that is aldehyde part undergoes oxidation, ketone part undergoes. Instead of phenyl, if a CH3 is there and this CH3 hydrogens will be removed away, anion will come, attack on the other compound, aldol condensation takes place. So, therefore, while having an example, one must be very careful to have an only aromatic case, so that there is no alpha hydrogen, both are eligible for the Cannizzaro. So, one undergoes oxidation, the other one undergoes reduction, that gives this type of the compound. So, this is once again a intramolecular type of the Cannizzaro reaction, but in this case both are identical, either one you can oxidize, but here again restricted, aldehyde undergoes oxidation, ketone undergoes a reduction to give the CHOH. This is also good example for the Cannizzaro reaction.